Hey guys, this is Mr. Fernando, and I'm going to be going over the Pythagorean theorem. I'll be going over just some general questions, as well as the word problems. So if you're looking for more of just the word problems, you might want to skip to the later half of the video. But I'm going to go the first 2 minutes of explaining where the formula comes from, breaking apart the parts of a triangle, and then I'll start doing some problems. So if you want to just kind of get into what the problems look like, again, skip around like 3 minutes, 4 minutes to see some of the basic questions, and then skip around closer to the end for the word problems. So the Pythagorean theorem. What is the Pythagorean theorem? The Pythagorean theorem is a formula, and what I have here is a way of kind of proving that formula. So I have a triangle right here in the middle, right? I'm going to do a little blue on this triangle. And this is a right triangle. A right triangle is a triangle that has a 90-degree angle. And as you can see, I've already kind of filled in some of the numbers. This A side of this triangle is 3 blocks long. The B side is 4 boxes long. And it is, the C side is 5 boxes long. And then notice how, again, I have these kind of boxes here, or it's those numbers squared, right? 3 squared is 9. 4 squared is 16, and 5 squared is 25. Now, the neat thing about the Pythagorean theorem is this. The formula comes from the second part, the numbers that I wrote. And it's a really cute thing, which is a squared, 9, plus b squared, 16, conveniently always equals the c squared, or in this case, 25. 9 plus 16 is 25. And look at that. If I put in the first box right here, a squared, it fits in right there into the c squared. And then you have b squared. I'm going to color in green right here. Again, that's 16 boxes, right? And you can fit in 16 right here. So what I'm coloring right now is 16 boxes. So in total, a squared and b squared equals c squared. And that's where the formula is. That is quite literally the Pythagorean theorem formula. A squared plus b squared is equal to c squared. So again, this is kind of just visually kind of showing how that kind of looks like, right? But that is the formula. So we're going to be using this formula to be helping us answer basically all of the rest of our questions. Before we get into that again, I'm just going to write the formula one more time. A squared plus b squared is equal to c squared. Now, what are the a and b's? Well, the a and b's are the smaller sides of a triangle, and we call those specifically the legs. So you might see problems where it says the legs of a triangle. What that's saying is the legs are the a and the b of a triangle. So the A and the B. Now, the important part to realize is that the A and B, it doesn't matter what side they're on. You could have this be B and this be A, or you could swap them. Because if you're looking at the formula, you're still adding these two things together to equal the c squared. So the c squared is a bit different. Legs are the A and B, and they are the shorter sides. So shorter sides are the A and B part of a triangle, or the legs. Now, the C can't be changed around. It is always the longest side. So the C has to be the longest side. And it actually has its own funny name. It has a really long name, and it's called the hypotenuse. The hypotenuse is the longest side, and it's the C side. And you know that it is because it is adjacent, or it's opposite to the 90-degree angle. So if you're never not sure what the B, A, or C is, look for the 90-degree angle, and the longest side is always diagonal to that longest side. So that's parts of a triangle, right? So again, if I gave you a triangle, right? Looking at this one right here, And yeah, I had to ask you which ones are the legs and which one's the hypotenuse. Well, again, the hypotenuse or the C is always diagonal to the 90-degree angle. So hypotenuse would be 25. The legs would be 7 and 24. Again, notice how I don't have A or B. It's literally just the legs. It could be either one. And then same over here again. It's a triangle that's upside down, but still, it's the longest side is diagonal to that 90-degree angle. So the hypotenuse in this one would be 13, 5, and 12, right? Again, the legs being the smaller sides of the triangle. So that's the formula. A squared plus B squared equals C squared. But let's see how we can actually use that to find missing sides, which is the whole point of using Pythagorean theorem. So I'm gonna go over some homework questions, and look at this one right here, right? So I have a homework question where I am given, looking at this, right? I'm given the A and the B. I am missing, I know that says X, I'm just gonna write as X or a C over it. I'm missing the longest side, I'm missing the hypotenuse, right? So if I wrote a formula for this of like what I have, right? If I want to solve this, I probably would start by doing A squared plus B squared equals C squared, right? That's the formula. And I am given my A and B, right? So quite literally, 6 squared plus 3 squared will equal my missing side length squared. So 6 times 6 is 36, plus 3 times 3, again, I'm just doing the squares, would be 9, and that's going to equal my C squared. If you add these things together, that would mean 45 is equal to C squared. Now, that doesn't mean this is 45 centimeters long, right? That would be a crazy length. But because it's the squared, I want the square root of it. I want to know what is C, or what is exactly just the C. So in your calculator, you would go, see, just need to turn it on. You would go, what is the square root of 45? Well, that's going to end up being C is equal to 6.71 as the C. So again, identifying that this is my A and B because it's not the longest side. So I plugged it in for my A and B, squared them, added them together, and the final step is finding the square root because again, I'm looking for that C, the missing side length. I'm gonna do it one more time on this one. So again, I'm given A and B. Doesn't matter which one you put it as. I can make this for the A, so I can do 4 squared plus 7 squared is gonna equal my missing side length, right? C. So 4 times 4 is 16 plus 7 times 7 is 49, and it's going to equal my C squared, right? Add these things together. That is going to give me 65. Whoopsies. 65 is equal to C squared, because again, all I did was I added them together. Again, A squared plus B squared will equal my answer as long as we square root it. So what's the square root of 65? Find that, and that is going to be C is equal to 8.06. So that's using the formula. But those are using the formula when you're solving for C, right? Now, if you're not solving for C, they're still solved the same way, or we're still using the same formula, but you got to be a little more careful. So this one's a little uglier just because it has some decimals, but it's still the same idea. I'm going to start with making my marker a little less thick, and I'm going to write the formula again. A squared plus B squared is equal to C squared, right? Still a formula. Now I'm going to start looking at what do I have. On this triangle, you have to stop and think to yourself that this 4.2, that's not a leg. That is a hypotenuse. That's the C. So this one's a little different. I'm given 4.2 is my C. And I'm given at least one of the legs. So you can put it for either A or B because again, it doesn't really matter. 3.7 squared plus b squared. Let's say the b is missing in this case. So this is what I have, right? It's still a squared plus b squared equals c squared. The only difference is you're given a mismatched piece of information. So, still do the same thing. Let's see what we have. If I do 3.7 squared, that's going to end up giving me 13.69 plus b squared is equal to 4.2 squared, which would be 17.64. My calculator's a little broken, so I was worried I was get the numbers wrong there. So look what we have here, right? I'm still wanting to solve for this b, right? This b is what I'm looking for. So I need to solve for it. So I need to get rid of anything that's on the side of b that isn't needed. So solving for b, I would have to subtract 13.69 minus 13.69 on both sides. And I now have b squared is the only thing left over, is equal to 17.64 minus 13.69. And that would give me 3.95. And again, I know it's decimals, but it's still the same idea. Last step is just finding the square root. So I want to know what the b is, not the b squared. Square root of that would be 3.95 is b is equal to 1.99 if you round it to the nearest hundredth place. And that's your final answer. So that's solving for not the hypotenuse. That's solving for one of the missing side lengths, right? Because you're given one of the lengths, or sorry, one of the legs, you're given the hypotenuse, you still got to place them where they're at. And let's see this with word problems. So word problems. Let's say I had this one. I really recommend drawing a picture each time you see one of these problems. See what the picture looks like, see where you think you can make a problem out of it. So a TV. So again, a TV is a rectangle. That's my flat screen TV. A TV has a width of 48 inches, so I know that it is a width of 48. Oopsies, sorry. Width I think means like this. And has a height of 32. And it's asking, what is the length of the diagonal of this TV? So it's wanting to know, specifically, what's that? What's the diagonal of this TV? And if you get rid of all the information that you don't need, oopsies, you have a triangle, right? This was the height of the TV, this was the width of the TV, and this is what I want to know. I don't know what the C is. So if I'm using my formula now, this is a 90-degree angle, this is my C. I have 32 squared plus 48 squared is going to equal my missing number. So let's start doing this. 32 squared is 1,024 plus, what is 48 squared? 48 squared is 2,304 equal to C squared. So I'm going to add these two numbers together because my A and B should equal my C. So answer plus 2024, and then I'm going to find the square roots of 3,328, because again, I want what the C is, not my C squared. And that is going to end up being 57.69. I think this was inches squared. Or sorry, just inches. That's my final answer, because I'm solving for C. This is actually how TVs are measured. Whenever you see, I have a 48-inch TV, that means it's 48 inches diagonally, not up and down or anything. Alrighty, let's see this next one. I see I have a picture frame, okay? So a picture frame is another rectangle. So let's draw that real quick. So this is my picture frame, and it measures 17 inches from one corner to the opposite corner. Oh, so that means this right here is 17 inches because it's one corner to one corner. And it has a length of 8 inches. So again, that 8 inches can go anywhere. It doesn't actually matter where this, the 8 inches goes. It can go right here, or it can go right here. The reason why I'm saying that is because we identified that the 17 is the hypotenuse. So the A and B can be changed around. So I can write my formula as 17 squared, because that's my hypotenuse, is equal to A squared plus B squared, which I'm given one of them at least. So 8 squared plus B squared, or if you really want to, you can make it A. It doesn't really matter, because it's the legs. We just want to find out what the other leg is. So let's say we are solving for A. So let's do 64 plus A squared is equal to, I don't know off the top of my head, what is 17 times 17? It is 289. And again, I'm gonna be solving for A squared, so I'm gonna subtract 64, and you'd have A squared is equal to the square root of 225, which I think that's actually a perfect square. It is. The square root of 225 is 15. So A is equal to 15. So again, you have to create your picture. Understand what part is missing. So in this case, it was a leg. I solved for a leg by, again, getting it alone, finding the square root, just like typical. All right, let's do one last one. Okay, let's say I am a tree. I'm drawing a tree. Whoop, whoop. And let's say, there's my tree right there. Super beautiful, right? And a tree is casting a shadow that is 10 feet long. If the distance from the top of the tree to the end of the shadow is 22 feet, how tall is the tree? So in this case, right, I am finding a Pythagorean theorem question where you have to talk about what the shadow is. So in this case, right, I'm gonna have to draw a line right here. This is a triangle, right? It's casting a shadow. The distance from the top of the tree to the end of the shadow is 22 feet. That's a key point, right? Of understanding like, top of the tree to the end of the shadow, 22 feet, right? If the distance from the top of the tree, the shadow is 10 feet long. So this part right here, the shadow is 10 feet long. Or another way to kind of just know what's the missing side piece is look at the question. In this case, how tall is the tree? Well, I don't know. I haven't been given it a number, and that's literally the question, right? So the question is, how tall was that tree that was casting that shadow? So what's this? What's the B in this case? So again, I'm gonna solve this one by going 22 squared is equal to 10 squared plus B squared. Again, I'm missing one of the legs in this case. So 22 squared is equal to 484. 10 squared is 100 plus B squared. So I don't know. I'm gonna subtract 100, and I have B squared is equal to 384. And so the final answer is, what is the square root of 384? So square root of 384 is, B is equal to 19.56, or sorry, just 6. If you round it, that's a weird rounding one. Feet long, that's how tall the tree is. So that's Pythagorean theorem. Hope that helps, and best of luck. The next one is distance formula.